We factored Friday, right? So we talked about factoring. We're always going to look for a greatest common factor first. If we have two terms, we're going to look for a difference of squares. If we have a trinomial, we just factor it easy. If we have more than that, we might use grouping. And when we are factoring to solve something, we're going to set it equal to 0 before we ever start factoring, right? Okay, so let's remind ourselves about more interesting factoring. Like Friday we did basics.
X squared plus cubes.
All right, so this is a difference of squares, but it's a quartet. But this is x squared being squared, right? And this is 4 being squared. So this is a difference of squares. It factors to x squared plus 4 and x squared minus 4. And then the second binomial will factor further.
X plus 2x.
X plus 2, x minus 2. Now we want to keep factoring like that in our minds as we look at some of our trig equations that we'll be solving today. It is possible that we might have to factor in a similar method. Or grouping. Do you guys remember grouping?
Yes.
Yeah, you group the ones that have something in common. You factor out the GCF.
Oh.
So here we want x minus 4. So what do we factor out?
Negative
Negative 1. So we have x squared minus 1 times x minus 4. What does this factor to? X plus 1, x minus 1,
I really like grouping.
And then X minus 4.
and x minus 4.
X equals plus or minus 1 or negative 1?
I wish we had that.
Okay?
You took out a negative.
I took out a negative 1, so it changed the x to a positive and the 4 to a negative.
Oh, okay, I didn't see that.
Yeah. So how might ours look today? And we might just have cosine written right here. Right?
It's the same thing.
Okay? So how would that change?
You just put cosine for it.
Yeah. Okay? So I'm going to undo that because it was crowded and ugly. All right. So today we're just really going to do some practice with factoring. Let's go ahead and pull out last night's homework. 61 I was asked about a couple times. I like 61. Where is,
Oh yeah, that's
this is cosine of sine of x. That's 6. That's not sine of x. Let me try again.
Oh, that's not cosine of x times sine.
No, it's cosine of sine of x. All right, now, so our identities and things kind of didn't help us out here. I can't multiply because this is not cosine of x times sine of x. It's not a multiplication problem. But what I have to look at is this. Where is cosine equal to 1?
0 to pi.
At 0 and 2 pi. Okay? So this in here, if it were cosine of 0, it would equal 1, right? So what I do is I set sine of x equal to 0. Or if it were cosine of 2 pi, it would work. So I set sine of x equal to 2 pi. Where is sine of x 0?
Adds pi over 2 and...
Is that
Oh,
zero?
no, never mind.
Is that zero?
It's pi and...
Pi and 0.
And 2 pi.
Okay. Where is sine of x equal to 2 pi? It's not. It's not. Okay. So these are our two answers between 0 and 2 pi. Right? That would work for this.
Wait, why didn't you set cosine equal to 1?
I did. Where is cosine equal to 1?
Oh, and that's 2 pi.
Yeah. So right here at 0 and at 2 pi.
Oh, that makes sense.
Is there a reason you wouldn't
Wait.
include 2 pi, or
What now?
why do you not include 2 pi
Yeah,
for the
why
range
is
of
sine-
possible values?
All of them didn't have the include here.
Oh, that's
I mean, we
okay.
could.
Screen recorded it and then screenshot.
Oh, I just realized that. Okay.
Okay, yeah.
Yes.
Okay, so yeah, like on the 63 through 68. Okay, so I could get like the first like answer. Like,
Yeah.
Like I know how.
Yeah, your calculator gives you the first one,
Yeah.
right?
So how do you get the
Okay.
second?
So let's do 63. We have have cosine of x equals 0.37. So to solve this is not a value we know from the unit circle, so we'd have to use inverse cosine, right? Alright, so we do inverse cosine.
And then you get
Oh, hold on. Let me make sure I'm in radian mode. Now I am. I'm going to try this again.
you get like 1.
Okay, so inverse cosine of 0.37. Alright, so that tells me I get 1.192 radians. Right? So if I thought about that on the unit circle, that is a nice big fat unit circle. We know that here's pi, which is approximately 3.14. And I know that here is pi over 2. And pi over 2 would be 1.57. Okay. So
Wait, hold up. Wait.
let's put it there.
Yes.
Is that good?
Making sure.
Okay. So, where else would the x value be equivalent to the same x value? Well, that would happen right down here.
Okay.
Okay?
And that's gonna
So that would be back 1.192 radians, right? Because this is forward. This isn't a positive direction, that many. Okay, so I want to go back. But I'm not using, I said between 0 and 2 pi.
So no
You-
negative.
So I can't do the negative. So what I have to do is I have to do 2 pi minus that 1.192. So I would punch it in my calculator. 2 pi
Oh, you can't leave it.
minus the A
And
and
then you get
S.
5.09.
And you get 5.091.
And that's how you do. So you just subtract. So you just
Mhm.
2 pi minus the.
Yep. For this one you do, because that's where it is. Now sine, if I was looking at the y value here, I would have had to jump over here.
But it will be the same thing, right?
So if this had said,
Like on
yeah, I would do pi minus that to get to right
Oh,
here.
just pi.
Yeah.
Okay.
I'm in.
All
And
right.
you want to your pi for pi day or partner? They both have you.
And then
All right, Pi Day is next week, and lots of pizza places have Pi Day deals.
it's also Stephen Curry's birthday.
We should.
Interesting.
I'll go by the party.
Yes, I
All right, Jonathan,
You're gonna go 30 also.
How did you get
Oh, I know this.
how did I get 1.192?
Yeah.
I did inverse cosine on my calculator, and I made sure I was in degree mode. Not degree mode, radian mode, because this is a radian.
Because you divide 0.37 by cosine. And that
All right, what else, guys?
that was it.
That was
That
it.
was all my 61 and how to
This
define
is like easier than like the first stuff that we did this unit.
Cool.
The one that we had to
It tastes good.
All right, so I'm gonna quit recording now because there wasn't a whole lot
Yeah.
of new.
I hate
Yep.